Hello guys, today I'm gonna start from where we finished the last time. I will introduce some new terms. So as usual, I'm starting from scratch. I'm just starting my Visual Studio 2012. I'm gonna open right now the project which we were working on. We just created a class called human, and we defined some properties, one method, just to help you recall what we did. This is what we have right now. So let me run the application to see if it runs. Yeah, my name is Stoyan, I'm 50 years old, my name is Ivan, my name is Default, and I'm 0 years old. Okay, so now I just wanted to attract your attention to something else as well. Here in the method, which represents actually the behavior of our object, we could use not only the properties but the fields as well, even though the fields are, as you can see here, private. This is what I wanna change here, just to show you that they still will work properly. Name, age, instead of properties I'm using fields. In the properties I'm using the fields to save the values of the properties. And here I'm gonna use the balance, which is a property but doesn't have a correlated field, balance. And I'm gonna say, and my balance is, and I'm gonna put here one placeholder. That's it. Okay, so let's see if everything keeps working. Start building. Here we go, and my balance is 4, my balance is 4, my balance is 4. If we want to make it a little bit more interesting, for example, instead of 2 by 2, we can base the calculation of the balance on the length of the name. For example, name length, this property, and you will see that everyone in our small world will have a different balance, which is based on the length of its name. Okay, so now let's continue further. Now, as I said, I want to introduce a new terms. The first term I want to introduce is called signature of a method. The signature of the method includes the name of the method, parameters, their type, their number, and their order. So if some of those are different, I'm not talking about the name, then we will have a different signature. In this case, we have a human without parameters, so this is one method, and human string name age is another method because the signature is different. The parameters are different. The number of the parameters, here we have 2 parameters, here we don't have any parameters. Even though the parameters are named the same way, for identifiers we use the name and age, but the type is different, we still will have a different signature. Okay, just as an example, I'm gonna create another constructor. By the way, the constructor is also a method, is a pseudo method, so that's why I'm using constructors to introduce the new term signature, because the constructors are also methods. And also pay attention on the fact that the return value is not included in the signature, because the compiler cannot make difference between the methods which have everything else the same but different return values. In the constructor, in any case, we cannot use the return keyword. Okay, so now I'm gonna define another constructor, public human, and I'm just gonna reverse the properties, the parameters, integer 8, string name. Okay, now I'm gonna do the same. This name name equals name, and this age equals age. Okay, now I can construct my objects in 3 different ways. Let's change here and call the newly created constructor. So right now I'm using all 3 constructors which I just defined. Let me run this and see if that works. Okay, we have done another refactoring. In other words, improving the design, improving the internal structure of our code, making it more readable, more reusable, without changing the functionality. Okay. Now, let me do something else here. I see in both constructors right now, I'm doing the exact same thing. What can we do in the terms of code reuse? Can we use again the code which we already have? Yes, we can. I actually showed this the last time. I'm gonna attract your attention again to this. Now I'm gonna send name and age. So what I'm doing right now is I'm just reusing the code of our firstly defined constructor. In other words, when we call the constructor without any parameters and the constructor with parameter age in the first place and string on the second place, in fact I'm calling the very same constructor, this one, which is in the middle, and this constructor is our working horse. The rest of the constructors doesn't do anything in their bodies. Okay, so I just have introduced the code reuse. The fact that we have 3 different methods, in this case there are constructors, with the very same names, but different type, number, and order of parameters, it's called overloading. So let me type this, overloading. And don't miss this with another term which is called overriding, which will be introduced in one of our next lessons. Okay, so let's see how can we overload this method. Introduce yourself, for example. Let's say I want sometimes the guys to be more verbose and tell more things. Okay, right now this is incorrect because I cannot have the methods with the same name, with the same names and the same signatures, with the same signatures, in fact, the same number of parameters, in this case 0. So just to make them different, I'll say string verbose, just to make them different, and I'm gonna type this word verbose, and I have been told something. Usually I'm gonna put verbose. I'm gonna send as an argument verbose. Okay, so right now let's ask person 1 to introduce himself and to be more verbose. So I'm demonstrating again method overloading. Okay, start, and here we go. My name is Stoyan, I'm 50 years old and my balance is 12. I have been told to be verbose. Okay, let's see how the code reuse can be used in this case. We see that in fact we do the same thing. We type on the console, my name is blah 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 blah. So this part actually can be delegated to our first method, and the second method actually just can concatenate, can just tell the rest of the story. Okay, let's do that. I'm gonna remove this first part. I don't need to type name, age and balance. In order to do that, I'm gonna use the code which I already have. In other words, one method is calling another method, and after that is just adding or augmenting whatever functionality it needs to be augmented. Okay, let me run this. My name is Stan, I'm 50 years old. Okay, I have a problem here. Of course, I just forgot to change the number of the placeholder. I'm being told. Let me run it again. This time it's gonna work. So this is about the signature of the method, overloading, and code reuse. This is what I wanted to introduce. Right now, let me show you another concept. What if we want, for example, to send more parameters to one method? Okay, I'm going to introduce right now the variable number of parameters. In order to do that, I'm going to type the keyword params. I'm going to say string, because we don't know how many parameters we're going to receive. That's why I'm going to accept them in an array, and I'm going to say friends. Why friends? I'm going to explain it very shortly. Let's say I want to be able actually to set the names of the friends of this guy. Let's say we allow the guys to have not more than 5 names of the friends. Okay, this is the goal I'm setting right now in front of me. Okay, I wanna allow the guys, when we construct actually the objects, I wanna allow the guys to add the names of their friends. Okay, so let's say this is John, and let's say this is Bruce. Okay, so when I'm using this way of constructing object, I want to be able also to say who the friends of this guy are, and I want to accept not more 5. Right now, this restriction will come from the fact that I'm gonna use an array to keep the names of the guys, and 5 is not a restriction which comes from params. Here I can continue typing the names of the guys. I can have as many as I want here, exactly like console write line. Okay, so right now I'm not using the names of the friends, but I just want to show you that the program will continue working the very same name. Okay, I can remove right now the friends, and because these extra parameters are optional, the constructor will construct the object, the program will continue working. Okay, so this params keyword should be put as the last parameter. I cannot move it here. For example, I cannot cut and paste it here in the beginning of the method. The compiler is not going to allow me to do that. Friends, this is the restriction, and as you can see, all the arguments which I'm sending, all the parameters, are the very same type. Okay, Microsoft Visual Studio is restarting for some reason. Okay, I hope it's gonna work. Sorry about that. My Visual Studio is very unstable on this machine. In any case, we will continue with the tutorial. We didn't lose anything. So, okay, just to add meaning to what we have done, let's say we want to save these friends. I will create private string. I will create declare one array, private string friends, and I'm gonna say that friends are not more than 5, and I even will set the default values. I will say default, just in case our objects have been created with our other constructors which doesn't get these parameters, and 1 2 3 4 5, and we eventually ask for their friends. If I see default, that means that their friends haven't been set. And just to be able to get their friends, I'm gonna define right now a method which I'm gonna call getFriend public. This is just for fun. The main thing here is just constructor with variable number of parameters. Public, this is gonna return string because it's gonna return the name of the friend. Public get friend, and let's say I'm gonna send an index because I want to see who is the first friend, who is the second, and so on and so forth. Index public, okay, and I'm gonna say return friends index. So let's ask our second guy, person number 2, who happens to be Ivan, who is his first friend. Let me set their friends so they're not default. If we ask him right now, he's gonna say that his friend is default. Console write line, and I'm gonna say person 2, which happens to be Ivan, as I said, get friend, and I'm gonna ask him for the first friend, which happens to be index 0. Okay, the program is not perfectly idiot proof, but I just hope that it introduces the concepts. Okay, let me say something else here. Of course, let's say my friend is, and I'm gonna put a placeholder. Okay, introduce yourself. That's fine. And right now let's instantiate an object using the second constructor, which accepts actually different number of parameters, and I'm gonna say my first friend is John, my second friend is Bruce. Okay, this is the term. This is how actually we define a method. It could be a constructor as well, because the method is a subset of the methods. It's just a method, pseudo method without return value. So this is how, if we have a method, we can send more, or if we don't know in advance how many arguments we are gonna send, we can use this trick actually. Let's ask now our second guy, who is your best friend? My name is Ivan, I'm 50 years old, and he still claims that his friend is default. Yeah, but because we haven't done anything in the constructor. Okay, so right now part of the job when we construct the object actually is delegated to our working horse, this first constructor. We are using a code reuse. We are using the code which is there. We're setting the name and the age here. And right now let's finish the rest of the job. Integer, this is my index counter. After that I will say for each string friend in friends, and I'm gonna assign the value. I'm gonna say even this friends, number of the friend equals friend. and I'm gonna increase the counter. Now everything should be working. So let's ask our guy again, who is your first friend? And here we go. It's John. Okay, this is the first part of this tutorial. This is the thing I wanted to introduce. Let me help you to recall again. So, what is a signature? The signature includes the name of the method plus the parameters, their type, their order. If we change the order of the parameters, we will have a different signature. If we have more than one method defined, in this case constructor, which is a pseudo method, then we will say that this method has been overloaded. Here it is, method overloading, and here it is, constructor overloading. Constructor is a pseudo method, it's a method again. Okay. And the third thing which I just wanted to introduce is variable number of parameters which we can send to a method. In this case, this method happens to be a constructor. Okay, now let's set another goal and see how we're gonna solve it. Now I'm gonna introduce static members, static elements of the class. Okay, now let's set a task. I want to know how many objects of the class human have been introduced across the entire application. Okay, I usually show different approaches. Okay, so first approach, the most stupid one, but we could do it. I just wanted to show my students actually different approaches and see their disadvantages. First and the most stupid approach is, let's say we will declare a local variable which we'll call counter equals 0, and each time we instantiate an object from this class we will increase the counter. Okay, I'm gonna show you the refactoring after that, and the necessity of what I'm gonna introduce and how we'll do it more elegantly. Okay, so this is how everything looks, and let's say I'm gonna write the population of my small nation is, and here I'm gonna show the counter. Okay, let's see how many people do we have in our small kingdom, in our domain. Okay, so we have 3 guys, which is correct, but let's say right now I want to create another method which is again static, public static it's not going to return anything, public static void increase population. And in this method I'm not gonna do anything else but just instantiate a new object of class human. Oh, please correct me. Okay, person 1, I'm gonna use the same identifier, variable identifier, because here I have a different scope. It's not gonna overlap. New human, and let's say here I will have Bruce, which happens to be 15 years old. Person 1, human. Now let's call this method before we ask about our population, and we will see that actually the population is not correct anymore. We see we have 4 objects, we have instantiated 4 objects, but unfortunately our counter is not working correctly, it shows only 3. Okay, why is that? Simply because the local variable counter doesn't know about the fact that we have instantiated another object. We could of course send the counter to this method, but what happens if this method is calling another one and we instantiate again object there? What about another one, another one, another one? So this obviously is not gonna work properly. It's working, it's partially working if we instantiate objects only in one method. Now we want to count all instances, not only in one method, across the entire application. So what could we do? The first thing is, okay, we ask ourselves, what if we create actually one field, we declare one field, integer here, and we call it counter, and we initialize with 0, private integer counter, and after that let's play smart. We ask ourselves, okay, is there a method which gets called always when we instantiate object? Yes, it happens to be. We have 3 constructors. 2 of them actually call only one constructor. Let's take advantage of this fact and let's increase the counter there. And let's see what happens. Let's make it public because I don't want to make it property. So I can reach this counter field from everywhere, from each one of the objects, and let's see what happens now. Okay, now we should ask one of the persons, because this right now looks like a property of our objects. So let's ask the first person if he knows about how many objects have been instantiated. Run. Unfortunately, it's not correct. Again, why is that? Simply because this field is owned by only one object. This object doesn't know about the rest of the objects. Now I'm gonna introduce one little modifier which is gonna change everything. It's actually a quantum leap. I just will type static in counter. In other words, I'm making this counter variable static. Counter plus plus. Okay, so now if we do this change, I'm not allowed to use anymore the word this. I didn't use it anyway, but if I have been using this, as you can see, I'm getting error, because this counter, it's not owned anymore by the individual instances. In other words, this is not an instance field, it's not an instance variable, it is a class variable. With the word static, it becomes a class variable which is common for all instances. And as you can see, in C# we cannot access such static field through individual instances. We have to access through the class. In Java is not like that. In Java, of course, you can access such static members through individual instances, but in C# they made a conceptual difference, and I think that's a step ahead. So you can access such field only through the class, because counter belongs to the class, not to individual instances. Let's run this program and see if everything works properly. Run it, and here we go. Ta-da! Now, as you can see, our approach is successful. It calculates the number of the population correctly. Okay, let me draw a picture right now. Let me go to the human class, and after that let's talk about that. This is how I'm going to represent our class human. Class human. In fact, when we define a new class, we define a new type, and all the objects belong to this type. This is a new type called human. So let's imagine that all instances, they are from this class and they belong to this class. We could have 0 instances, but right now I have one instance which is Stoyan, another instance which is Ivan, the third instance which is default, and the fourth instance, which is Bruce. The properties, I would imagine, are something like that. I imagine the objects like biological entities, okay, like small cells. And on these hooks, actually, we can attach variables, values actually, from a given type, which make all this object individual. Okay, so on this hook actually we have Stoyan. On this hook we have 50 years. This hook actually can hold only integers. This hook can hold only strings. The same here. This guy is Ivan, and it happens to be 20 years old. This guy is default, and it happens to be 0 years old. And this is our Bruce, which is 15 years old. Bruce is 15 years old. Okay, now when for first time we declared the counter, what we did in fact is we created another hook here in each one of our instances. This is our variable counter, our field counter. And as you can see, no wonder why each one of the instances cannot count the number of the instances which belong to this class across the application, because each one of them actually has a separate counter. Okay, during the instantiation we call the constructor. The constructor just increases the counter with 1, so each one of the instances will say, okay, I'm alone. Only one instance exists in our domain, in our world. But when we added the modifier static, what in fact we did is we are not attaching this hook anymore to individual instances, but instead we have it here attached to the class. This is our counter. So our counter is common for all these instances. All these instances actually can access the counter, can change the value, and can read it. Okay, so let me actually give you another perspective. Let me save this. I'm gonna save it on the desktop, eventually add it to the video or to description, or maybe not. Okay, so I imagine these instances as spheres, biological spheres, maybe cells, like living creatures. So if I look at from another angle, actually, I still see them as spheres, like that. This is Stoyan, this is Ivan, this is default, and this is Bruce. And here it is, our common field. This is counter. Each one of these individual instances can read the value or set the value, but as you can see, this field is only one. It's only one for the entire class of objects. In other words, the counter is common for all these instances. Counter. Okay, let me save this as well. I'm gonna name it 2 just to be simple, and we'll continue from there. So as you can see, we made a quantum leap here. Let me show you another use case, just to give you an idea how can you use this idea, the static fields, another way. Okay, let's say we want all of our instances to have a property called nationality, and I want to change the nationality. At the same time, I want to be able to change the nationality of all my instances with one shot. Changing a property of the entire class would change the nationality of all instances. Okay, let me first declare this this property with the field public static string nationality, and I'm gonna set it to Bulgarian because I'm Bulgarian. Oops, Bulgarian. Okay, so make our nation a little bit more popular. Okay, so now public static string nationality Bulgarian. I hope you have fun. Okay, now in the method where the guys introduce themselves, let's ask them also to introduce their nationality. My nationality is, and I'm gonna print here Bulgarian eventually, and after that we'll see how we are gonna change that. Okay, nationality. Okay, so let's see now how everything looks. Voila! All of the guys now report that they're Bulgarians. Okay, let's change the name of the entire nation. Let's tell them that they're Germans, for example. Okay, before they introduce themselves, notice that again this field, this property belongs to the human, to the entire class, and I'm gonna say nationality, and I will make all of them Germans. How convenient. With one shot actually we change one property of the entire class of object. German. Now all of them will claim that they're Germans. Okay. Why Germans? Because they're in Europe as well. Okay. Now, it's not a very good idea actually to expose a field. We were talking about that before in the previous tutorial. It's not a very good idea to give access to the field of a class. So let's make it private, and I'm gonna introduce static properties. There is a special syntax construction which is gonna allow us actually to represent the property better. This I'm gonna say it's private, and I'm just gonna keep the value of the property in this variable, which is private static string nationality, and in order to set and get I'm gonna use a private property. So I'm gonna say public, not private of course, it's gonna be public static, this is what I wanted to say, public static string nationality, and here I'm gonna set the getters and the setters. Get, oops, return nationality, and I'm gonna set the nationality again. Set nationality value, and voila! Now this is we are following the best practices. Instead of just accessing the field directly, we are going through a property which happens to be static. So this is the place to tell you that we have 6 elements of the class. The elements are, let me recall again, the declaration, the line where we use the class keyword and the name of the class. After that, the body. This is the second element of the class. The body is from the opening curly bracket to the closing curly bracket. After that, I introduced so-called fields, variables which are declared in the body of the class. After that, I introduced the properties. The properties are between the fields and the methods. There are special syntax constructions which help us actually conceptually to to distinguish between the methods and the properties. After that we have the 5th element, which is the constructor, and the 6th element of the class are the methods. Constructors are methods. Okay, let's see now where can we use the static modifier. We can use it in all 5 elements except the body. Only in front of the body there is no sense to put static, for example. There is no sense. But For all other elements, we can use modifier static. So in other words, we for example can say static class human. Okay, in case we do that, that means the class, the instance, cannot be created. In other words, we cannot instantiate objects from such class, static class, like that. Oops. We cannot instantiate object static. Okay? We cannot instantiate object of such a class, and all its elements should be static as well. I'm not gonna demonstrate this. This is very rare case, especially if you're gonna follow the object-oriented path, this style, this paradigm, because in other words, the class turns to be right now a container for static methods. In other words, you're practicing right now again a procedural approach. In fact, you're just having variables and methods inside of a class. So this is another viewpoint. This is how you can look at the static classes. Actually, they're containers for methods in this case and other elements, but they cannot be instantiated. So procedural approach, it actually encourages the procedural approach. And as I said, as I explained it already, all the members, all the elements should become static if you declare, if you make the class static. Okay. Now I introduced to you how can you use the static fields. After that, I show it to you how to use the static properties. We can use the modifier static in front of the constructors and in front of the methods as well. But let me back off a little bit, introduce something else, and we will get back again to the static constructor. Okay, what if I wanna have a constant across the application? It's very easy to do it. You just say here public const, and after that, let's say it's a double, and I'm gonna use p 3.14. Okay, this is how you can declare a constant. As you can guess, it's a static. You can access it through the class, through the name of the class, cannot be changed, and the very important thing is that the value cannot be set dynamically when the program is running. In fact, what the compiler does, it just replaces whatever the constant it used with its value. Okay, so let me print this constant. I'm gonna say console write line, and notice this human, I'm accessing the constant through the class, and here we go, p start, and here we go, 3.14. Why we're using a constant? Let's say we're using the very same number 3.14 everywhere across our application on 100 places. We're calculating different radiuses, a volume of spheres, whatever. So if tomorrow somebody asks you to increase the numbers after the decimal points, you have to go through entire application and change the hard-coded value. Instead of that, you can use a constant, and when somebody asks you to increase the precision, for example, you go only here and you add more digits. That's all. This is the reason we are using a constant. Okay, there is another modifier which is called read only. Public read only, let's say again double, only read. I'm gonna call this variable right now like that, and I'm gonna assign a value 5.6. Okay, notice something now. If you use this modifier read only, double, only read, there are only two places where you can initialize this variable. As you can guess, this field will be only for reading. you set the value only one when the program runs. This is very important, when the program runs. And after that, the value cannot be changed. You can only read the value. Where are the places where you can set the value? The first place is during the declaration. You can initialize the value of this variable. And the second place is somewhere in the constructors. Okay, so probably here I will say this only read, and I'm gonna set 2.7. Okay, because I'm curious to see right now which value will prevail, the one which I set during the declaration or the one which I'm using in the constructor. And I'm gonna tell you in advance, this one value will be taken, this one will prevail. But as I said, you can set the value on only two places, either in the constructor or during the declaration. Okay, let's try this. Console right line, and I'm gonna say here, I cannot do it here because, as you can see, this is an instance variable. In other words, I have to go through a person, an instance, person1, and I'm gonna call only read right now, just to see the value, which value has prevailed. 2.7. As I explained, the value which is set in the constructor prevails. Okay, now let's go one step further. What if we make this field static? Where can we set the value of the static read-only variables? Look at now, we are not allowed to use the this anymore, and now we can access this field only through the human class. Console right line, and I'm gonna use here human only read. Okay, only read cannot be set here in this constructor because it's static, and on top of that, only read fields can be set only in a static constructor. So here we come. Now I have to introduce the static constructors. The static constructors get called when for first time objects have been instantiated for a given class, or when somebody tries to access, to read, for example, a static member, a static field, a static property, or calls a static method. Okay, so let me introduce you now the static constructors. Okay, static, notice we don't have access modifier. I'm gonna say human. They don't have parameters, any parameters, and usually the static constructors are used to set static fields or properties. Okay, human static only read, and I'm gonna say 2.7, and let's try and see if that works right now. Okay, start, and voila, 2.7. The value actually have been taken from the constructor. So the static constructors, of course, doesn't exist to set the values only for the read-only fields. As I said, the static constructors have sense to use each time when you want to initialize, to set the values of fields or properties, static fields or properties in a class, and they get called either when somebody tries to access such static fields or properties, or when for first time an object have been instantiated. Okay, so I introduced to you, just as a short recap, static classes. I just explained it what they are all their members should be static. They turn out to be encouraging procedural or structural programming, because in this case object cannot be instantiated from such a class. All members should be static. After that, I introduced to you the static fields. After that, the static properties. Right now I showed to you the static constructors, which are used to set the values of the static elements. And now the fifth element which can be static is the method. Okay, so let's say that right now I want to calculate the national income of our small domain, on our small kingdom. I have to use a static method, because as you can see, this method belongs to the entire class. The national income is calculated based on the static field counter, which counts all the instances in our small kingdom. And also I should be able to call this method when even not one instance have been created. I should be able to call the entire class. Okay, what is the national income? And if there are no instances, it should be 0. When there are instances, let's assume that each one of the instances has in its pocket $10,000, and I will calculate the income with a very simple formula. Public, it's going to return double, static, of course, static, to make it a method of the class, not of the instance. Static double, and I'm gonna say calculate national income, and that's it. Now it's gonna be very simple. Return counter, and I'm gonna multiply by $10,000, and that's it. Now I will be ready to calculate the national income of our small kingdom. Console write line, and I'm gonna say human. Pay attention on that. I'm again going through the class name. Calculate national income. Let's see if that works, and after that we'll make a short recap. $40,000. The national income is $40,000. As you can see, I introduced to you a static method which belongs to the entire class. If there are no instances, of course, this method will continue exist, this method will continue work. We always can access through the human class, and it's gonna calculate properly the national income. The national income is, and I'm gonna put here placeholder, and let's run it again. After that I'm gonna make a summary, and we are done. Now here we go. The national income is $40,000. Okay, so the summary. I just introduced to you the static elements of the class. We have seen that 5 elements of the class could be static. The class itself could be static. The field could be static. The property could be static. We could have a static constructor, which is a very rare use case, but it exists. And the fifth element, we can have a static method which belongs actually to the entire class. Before that, I introduced to you the term signature of the method. After that, I showed to you how you can overload the constructors and the methods. How can you reuse the code of the constructors and the methods? Thank you for your attention. See you the next time. Hopefully this was helpful for someone.